You're most welcome to our educational channel, Molten Heights Education Services. So today we are going to look at techniques of differentiation, and in the first one we are going to look at the product rule. So these techniques are like the methods that you can use to differentiate different kind of functions. Because you might have a function, say y is equals to x plus 2 multiplying x plus 3. So you find that this function y is equals to x plus 2 is a product of two different functions. So how are we going to handle the differentiation here? We could open the brackets and simplify, but we can use a rule, say product rule, to handle this kind of functions. So what we are going to do, we shall say, suppose u and v are functions of x. Then our y is equals to u v. So allow me to call this equation 1. So from the differentiation of using the first principle is what we are going to use here. So it means we shall add small increment in y and small increment in both sides of u and u and v. So we shall have our y plus small increment in y should be the same as u. Now this small increment we are going to add into the two functions of x. So it means here we shall have plus small increment in u multiplied by v plus small increment in v. So let's open this bracket and simplify. On simplifying, we shall have this side remaining the way it is equals to multiply this and this, we have uv. Then multiply this and this, we have plus u delta v. Then multiply delta u plus this times this, we have plus v delta u. Then this and this will give us plus delta u delta v. So what do we have here? I think we can call this equation 2 now. What we are going to do, we shall have equation 2 minus equation 1. So that one will yield for us y plus delta y minus y is equals to, we write this the way it is, then we add, we subtract uv from equation 1. So what we shall say that our y will cancel out with this y. Then this uv, negative uv, will cancel out with this positive uv. And we shall have our function to be now, we shall remain with delta y is given by what is remaining this side. I can write this, I have v delta u plus u delta v, then plus what is remaining here, which is delta u delta v. Very good. So what can we do? We are going to divide both sides by delta x. So we shall have cal y over cal x is equals to, now here we shall have v cal u cal x or delta x plus u delta v over delta x or small increment in x, then plus delta u delta delta x times delta v. Now remember, when we take limit as delta x tends to infinity, what will happen? We shall have delta is what we are going to say as x as delta x tends to infinity or to zero, rather to zero. We shall see that our curl u will also tend to zero, curl v will also tend to zero, then curl x, curl y, curl x will tend to dy dx. Then our curl u, curl x will tend to du dx. We shall have curl v, curl x will also tend to dv dx. Now when we substitute these conditions in our equation, let me call it star, since we are still working on it, we shall say that we are going to have dy dx is going to be v, this is curl u curl x, which is going to become du dx, then plus this is u d curl v curl x will become dv dx. Then lastly, this one will have plus d du dx times, since we say that curl v will tend to zero, here we shall have 0 there, making the whole of this part to go to 0, meaning we shall have our derivative to be so in simple terms, this is the rule that we are going to apply, meaning that when we are differentiating a function which is a product of each other, we shall first of all maintain the second function constant, then differentiate the other function, this is du dx, then we add plus the first function, we maintain it constant, we differentiate the second function. Let's look at one example to clarify this. Thank you. That will be in our next video after this.